All right, we're going to look at our Unit 5 vocabulary in a little bit more depth here. So go ahead and be getting your journals out. Okay, with this vocabulary, we're going to look at a little more depth, just word by word. Okay, the first word we're going to look at is the direct variation. Now, a direct variation is a linear relationship between two x and y's that has a constant unchanged ratio k and can be represented by y equals kx. Okay, that would be your formula for a direct variation. If we were to look at a graph of a direct variation, the key to a direct variation is that it's always going to go through the origin there. That is the key to a direct variation. If it does not go through the origin, then it cannot be a direct variation. Pretty simple, it goes through the origin, is a straight line, it's a direct variation. There are two things that make it a direct variation. It has to go through the origin and be a straight line. Okay, the next thing is a function. We're going to spend a little bit of time on this one. Okay, there are pretty much always 2 to 3, maybe even 4 STAR test questions over functions, and these are too easy to miss. Okay, with a function, the key thing with a function is you're going to test it with the vertical line test. Okay, the vertical line test. Now, we should all know a vertical line is a line that is straight up and down. That is a vertical line. So, draw a couple of examples here. Okay, have line doing this crazy stuff here. Okay, the vertical line test, you take a vertical line and you're going to run that vertical line from left to right across your graph to determine if it ever touches your line in more than one spot at the same time. So we're going to run it across here. It only ever touches this line that we drew in one spot at the same time. Okay, it touches one spot here, touches one spot here, one spot, all the way through here. Okay, this would be an example of a function. However, on this one here, it only touches in one spot there, but then right here, down this middle, right down your y-axis, it touches in 1, 2, 3 different spots all at the same time. This would not be a function. A function has to have one x value with each y value. That means you cannot repeat x values. Now you'll notice here, it is the vertical line test, not the horizontal line test. The horizontal, your y's can repeat, and it is still a function. The key with functions is that your x values cannot repeat. Okay, at x equals 0, or your y-axis, you have 1, 2, 3 spots that your line hits your vertical line there. Where over here, it only ever touches in one spot at a time, anywhere along that line. So this would be a representation of a function, and this one would not. Okay, the next word goes right with function. That would be mapping. Mappings, they will give you an x with some more numbers in it. 1, 2, 3, and 4. And then they will give you a y with some numbers in it also. Now, when you're dealing with a mapping, the first thing you always have to do is you have to write the coordinates out to the side. Now, when you're writing these coordinates, we're going to go x, then y. It's just a mapping is just a different way to write coordinate pairs. The coordinate pair for this, you get an x, and then you pair it with the y that they give you, an x, pair it with the y they give you here, you get an x, pair it with the y that you're given, and the last x, and pair it with the y that you're given. Now we know these are our x's, these are our y's. Okay, with functions, all you care about is your x's. That's all you care about. I'm sorry you couldn't see that there. All you care about in functions are your x's. So we don't even want to look at our y's. You can completely get rid of those y's. Your question is, do your x values ever repeat? If your x values do not repeat, that is good. That is a function. Okay, so let's look at another example down here. 2, 3, 4, 7, and 6. The first thing we need to do is we need to write down our coordinate pairs. We've got a 2, 7, a 3, 7, and a 4, 6 for our x's and y's. Okay, we get rid of our y's. We don't need those. And we look at our x's. Do our x values ever repeat? Okay, we got a 2, a 3, and a 4. No, our x values do not repeat, so that is good. That is a function. Okay, now let's look at an example of one that would not be a function. We have 2, 3, 5, 6, and 7. X and y. Okay, your coordinate pairs here would be 2, 5, 2, 6, and 3, 7. So we look, do my x values ever repeat? Well, we have 2 2's there, and then a 3. They do repeat. We have 2 2, so this would not be a function. All right, and that is it for functions. Okay, the only other words that we're going to look at here, I'll go to a new page. The only other words we're going to look at here, one of which is slope. We've looked exhaustively at slope, but just if you need a reminder, slope is the m in the y equals mx plus b. So that would be your slope. And the last word we're going to look at is unit rate. Okay. A unit rate is things like miles per hour or miles per gallon. Or if you're talking about putting air in a car tire, it would be PSI. That's pounds per square inch, etc. Anything else, anything like that. Okay, you can add your own examples there if you would like. It's anything with a 1 or per. Okay, the key thing that we need unit rates for, unit rates are used or needed to convert between units. Okay, we know that 12 inches are in 1 foot. So we can use that to figure out how many inches are in 1 mile, because we know that 5,280 feet are in a mile. We know how many inches are in 1 foot. You can use those two unit rates to figure out how many inches are in a mile. Things like that are what you need unit rates for. All right. Go ahead and finish up those notes. Go ahead and like and subscribe to my page because I have awesome YouTube content. And feel free to email me if you have any questions or need any help with any of your work while I'm out. Thanks, guys.